The Horn of Africa is a divergent on-continent boundary located here between the African and Arabian plates. These are both continental plates. This model shows this boundary and how it has formed a rift. At first, the two plates remain next to each other at rest. Then, the convection cycle in the mantle below begins to push the plates apart. Eventually, the rift becomes deep enough that it drops below sea level, allowing water from the Mediterranean Sea and Gulf of Aden to pour in. So, why is this a rift and not a trench? This is a rift because of the density and thickness of the continental plate. This can be modeled by using a tortilla chip and some bread. The chip, like an oceanic plate, is thin and dense. When pressure is applied, it snaps, suddenly forming a deep trench. On the other hand, the bread, like the continental plate, is thick and less dense, so when pressure is applied, it slowly tears and pulls apart. Therefore, the rift does not go straight into the mantle and rather slowly extends and deepens. This is what the Horn of Africa looked like in the past, when it was part of Pangaea. Lastly, this map shows how the site has changed into what it is today. Africa can be seen slowly drifting to the east, and once it stops, the chunk of land which now makes up the Middle East splits off and joins with Eurasia. So, that is what is happening at my case study site, the Horn of Africa.